This video segment continues our examination of greenhouse gas emissions from electric power plants. It focuses on nuclear, hydroelectric, and wind power. Its major points are: number 1, fears of major accidents have stalled the use of nuclear electric power. Number 2, most of the best locations for hydroelectric power are already in use. Number 3, wind power is expanding despite difficulties in site selection. 3 major accidents have occurred at nuclear power plants. A reactor core at 3 Mile Island Nuclear Power Plant near Harrisburg, Pennsylvania, melted down on March 28, 1979. Fortunately, most of the radioactivity was contained and no one experienced severe injuries. On April 26, 1986, a reactor at the Chernobyl nuclear power plant in Ukraine exploded and sent a plume of highly radioactive material over large portions of Europe. 237 people suffered from acute radiation sickness, 56 of whom died within a short period. Millions more are exposed to above normal doses of radiation. Today, radiation levels remain so high near the plant that all residential, civil, and business activities are forbidden within a 30-kilometer radius. A major earthquake generated a tsunami that hit the northeast coast of Japan on the 11th of March 2011, flooding the 6 nuclear reactors at the Fukushima Daiichi power plant and destroying all cooling for the reactors. In the days that followed, 3 of the reactors experienced full meltdown. Hydrogen explosions and fires damaged the containment of 4 reactors. Radioactive water leaked into the ocean and contaminated groundwater for kilometers around the plant. Most countries have advised their citizens to evacuate an 80-kilometer radius from the plant. Cleanup of this area will require a workforce of hundreds or even thousands and take years or decades. The accidents at 3 Mile Island, Chernobyl, and Fukushima cast a pall over the nuclear power industry. This, together with the relatively low cost of coal power, the difficulties in disposing of nuclear waste, and the volatility in uranium prices, have deterred construction of new facilities. At present, 435 nuclear power plants operate in 30 different countries and generate about 15% of the world's electricity. Worldwide, only 29 new nuclear power plants are under construction and will begin operation during the next decade. 7 are in India, 5 in Russia, 4 in China, 1 or 2 in other countries, but none in the United States or Western Europe. By contrast, 6 older plants in the world closed down permanently in 2006. The Fukushima disaster prompted Germany and Switzerland to announce their intentions to cease use of nuclear power by 2022 and 2034 respectively. Nuclear power plants harness the energy released during nuclear fission. In this process, unstable isotopes of uranium or plutonium in fuel rods expel neutrons and disintegrate, respectively, into thorium or uranium. A tiny fraction of the mass of the original materials converts into energy, E equals mc squared. But this releases vast amounts of energy because of the high conversion value. Neutrons expelled from the fuel rods may strike other uranium or plutonium atoms and induce them to expel neutrons, building a self-sustaining fission reaction. The critical mass of fissionable material in the fuel rods is always below that necessary to start a nuclear explosion. Nonetheless, if the fission reaction accelerates too quickly, a reactor core may overheat and melt down as they did at 3 Mile Island, Chernobyl, and Fukushima. To control the rate of the fission reaction, and thereby the temperature of the core, nuclear power plants insert control rods of neutron-absorbing silver, indium, cadmium, or boron between the fuel rods. Moreover, elaborate heat exchange systems transfer energy from the reactor core to a steam generator that converts water to high pressure and high temperature steam. The components outside the containment building are common to most types of electric power plants. Steam, which the reactor core generates, drives turbines that spin electrical generators. Nuclear power has major advantages. It is clean, in certain respects, because it neither releases significant amounts of greenhouse gases nor air pollutants such as particulates, sulfur dioxides, or nitrous oxides. Known reserves of fissionable materials are adequate to supply nuclear power plants at the current rate for roughly 50 years. If the price of uranium should warrant it, say above $200 per kilogram, exploration for new sources, new nuclear reactor technologies, and fuel rod reprocessing have the potential to supply nuclear fuel for several centuries.